So these were day one configs, right? What do we mean by day one config? Day one configs are like when you install a firewall, it's very fresh and you need to set up the GUI, you need to check if everything is working, you need to allow access, very simple access, right? Wherein you'll see if the traffic is passing through the firewall or not. Security rules are taking a hit, NAT rules are taking a hit, right? The interface configurations, the routing, all these things are very basic day one configs, right? So we then discussed about zones, what are security zones. However, because this is just a boot camp, so we reviewed layer three zones, right? There are a few other zones like tab zones and all those. We have not discussed on those. Security policy between zones. We have created security policy, a basic policy where we call it as allow internet, and we were allowing traffic from your trust towards untrust. Uh, then again, these policies were purely based on trust, and I mean, these were like zone based, right? We did not add any granularity to it. By granularity, I mean we did not. Uh, by granularity, I mean we did not add any source address or destination address or any applications for that matter, right? It was just allowing the traffic from a zone to a different zone, inter-zone rule, right? After that, we have this was not in the topics list, but I have added it so that for the sake of completion, that we understand interface management profile, right? By default, any traffic which is directed towards the firewall will be denied or dropped, right? So in order for firewall to reply to this ping, we had to enable something called as interface management profile. So we went ahead, we configured HTTPS, SSH, and ping on a trust interface, right? So let me bring that. I'll quickly draw that diagram, how it looks, right, for the people who might have not joined the earlier class. Uh, right. So this is my PA firewall. This is my trust interface, Windows machine, right? This is my switch, right? And this is my, so this is Ethernet 1/3, Ethernet 1/1, and this goes to a ISP router, right? I think this is too wide. Yeah. This goes to my ISP router, right? So this interface over here had an IP address of 172.16.1.1, and it was acting as a default gateway for these machines, right, which were in your LAN segment. We call this as trust zone, right? So in order for this machine to be able to ping this interface, which is the default gateway, we allowed or we applied interface management profile, interface management profile on this interface, right? And we allowed what? HTTPS, SSH, and ping, right? Now, these three services are for firewall, right? It's not for a pass-through traffic. It is for the PaloAlto firewall itself, right? So when we allowed HTTPS, we are able to access the GUI of the firewall, right, from this machine or this machine, either of these machines, right? Because this is applied to the interface. Huh? But however, we need to, again, I have mentioned this in my last class as well, that you need to be mindful that you are accessing this GUI by this IP address, right? So GUI, then we were able to access the SSH of this firewall, and then we were able to ping the interface, right? So this is a bit important in production environment, right? Wherein you should not allow this or apply this interface management profile on your untrust interface. This is not acceptable. But definitely you can, again, there might be some norms on different organizations, right? So every organization has a different compliance that they have to follow. So if it allows, you can apply an interface management profile, at least for testing, so that you'll be able to ping your default gateway and see if the firewall is reachable, it's replying, and these kind of things, right? And this was verified in the labs. Uh, Further, we had discussed about the NATs. We talked about the type of NAT, we covered source NAT, right? We did not cover the destination NAT because DNAT gets a bit complicated, and this bootcamp is like sort of introduction only, right? Because we don't want to get into the too much depth where things become overwhelming for you guys, right? So we covered source translation, right, or source NAT, wherein we saw there were three types of NAT, and the fourth option was none, wherein we call it as a no NAT, right? And first one was DIPP, dynamic IP and port, and second one was your dynamic IP, wherein you used to provide a pool of IP addresses. Dynamic IP does not, translate the port, right? It just changes the IP address. And then we had static IP, which was like one-to-one mapping, right? So these were already done in the lab. So we have completed till this part, right? So these topics are done. Today we are going to talk about application filter. Then we'll see about this. We'll talk about this maybe in our next class, wherein configuring URL filtering, because I need to create a background so that you guys actually understand how things are working, right? So this needs a bit of explanation and making you guys understand how this URL filtering actually comes into picture. Okay. So today we'll talk about application filter, we'll talk about ECMP, and we'll talk about policy-based routing. Okay, these are the three topics that I intend to cover today. Before we jump directly into application filter, we need to understand what is app ID, right? So I'll again add a new topic over here. So we'll start with app ID today, right? So the reason I keep on maybe, modifying the syllabus or adding on top of it so that you understand what's the main topic, right? So if you have to understand what application filter is, you need to understand what app ID is, right? If you don't know app ID, then it will be difficult for you to, comprehend application filters functionality. Okay. Uh, cool. Let's get started. I'll quickly clean this up. Yeah, okay, this looks cool. All right. So, what is app ID, right? What is app ID, right? App ID it's a signature based or behavioral based, or you can call it as pattern based, right? Uh, Algorithms that identify the applications, right? What do I mean by this, right? Now, obviously, we have a PaloAlto firewall in the environment wherein your traffic is passing through the firewall, right? And the firewall has the capability to allow and deny the traffic and also do application identification, right? Now, uh, as this statement says, this is based on signature or behavioral or pattern, right? So there must be a pattern or something, an algorithm that will be able to identify your application, what kind of application is going through it, right? For example, let's say you are trying to open Facebook, right? You open facebook.com on your browser. Now, if I select application as Facebook in my security rule, right? In my security rule, then I should be able to take an action on Facebook, the traffic which is headed towards Facebook, right? So, for example, in your environment, you have been asked to block all the social networking sites. On top of it, I mean, uh, Facebook is strictly denied, is it should not have an access, right? So what you do, you go ahead and create a rule saying trust to untrust is, and the application over there is Facebook, and then you just deny that rule. Yeah, deny that traffic, right? So no one is able to reach out to the Facebook, right? But nowadays, if you'll see, Facebook in itself has so many sub apps, right? There will be sub applications. What do we mean by sub applications? Is so you might have seen Facebook chat, right? For an example, right? Then we have something called as uh, Messenger, right? And then posting, right? Where you post those things, right? So these are like sub applications wherein you go ahead and do some other task as well, right? So Facebook is a whole big application, and these are sub applications wherein you can chat with your Facebook friends, right? Messenger is again a separate application wherein you can install a Facebook Messenger, right? And then posting, wherein you create posts and then post it on your wall or whatever it is, right? So these are sub applications. Now, obviously, for example, in your environment, your administrator comes, or your lead comes and says, okay, let's do one thing. We don't want to block Facebook 100%. All I want is people should be able to see the Facebook page. That's okay. They can be able, they should be able to log in, but they should not be able to, chat or do a post, right? Because they are a bit afraid that if something internal information gets leaked to public domain, then that would be an issue, right? So then what you do, you go ahead and block Facebook chat. You create a security rule. You create a security rule, right? Wherein first thing what you do is block Facebook chat, right? And Facebook post. Okay. These two are blocked. And then you create a rule which will allow Facebook. Okay. What happens? When we create rules, we have discussed this in our earlier classes. It is always a top-down approach, right? So the rules will be evaluated from top towards bottom, right? So first rule is block Facebook chat and Facebook post. So now, for example, you open a Facebook page, right? So that Facebook page is not going to match these applications. Okay, this is gonna match this rule, allow Facebook. So you are able to open the Facebook page. Then you will be entering your credentials. You are able to log in. Things are fine. Still, this rule is taking a hit because this is allow Facebook. We do not see any applications over here as of now. Okay. Facebook chat. Then what you do? There is a messenger over here, or something, chat over here, Facebook chat, on which you click and you try to chat to your uh, Facebook friends or peers, right? What happens is the moment you do this, the application ID will change. The app ID will change, and you will be able to come and when you see the uh, security rules evaluation, it's going to match this rule, right? And once it matches this rule, we have defined an action of block, and this traffic will be blocked. So you'll not be able to chat with your peers. Okay. Similarly, same it goes for the Facebook post, right? So this is how you can control the application flow in your environment. Okay, we'll see this in a minute. Before moving to the labs directly, I just wanted to also discuss something called as application tunneling, right? The whole purpose of having app ID is security. I mean, definitely we want to have a granular control as to what could be accessed, what cannot be. But at the same time, the security is also very important, right? So uh, having a next generation firewall, the whole idea is security, correct? So application tunneling. What do we mean by this application tunneling, right? We have had a simple discussion during our introductory classes as well in the I believe day one or day two, right? So application tunneling is nothing wherein uh, The layer 4, that is your port information, and layer 7, that is your application payload, okay, do not correspond to each other. What do I mean by this, right? When I say layer 4 and layer 7 information do not correspond to each other. So let's take a simple example, okay? Wherein layer 4, for example, port 53 is for DNS, right? That means what? The layer 7 information should be a DNS payload. It should be a DNS payload, correct? So this should be your layer 7 information. This should be your layer 4 information, right? Now, what happens is, now let's say there is a malicious software or some malware, for example, right? Something malicious software is what is called malware, right? So there is some malicious software that is installed in your environment. What it does is, let's say you do not have an NGFW in your environment. There is no NGFW, okay? It's just a NGFW is not there in your environment. It's just a traditional legacy firewall that has only visibility till layer 4. Okay. In that case, what happens is, let's say that malicious software very smartly, it masquerades this port 53. Okay. It's sending the traffic over port 53, but the payload it sends is malicious, right? Uh, It could be anything. It could be reaching out to command and control. We call it as C2, right? Command and control is like wherein there is a malicious server out there which is trying to gain access to your environment, right? That could be that. Or it could be reaching out to a server to download some binaries that might be harmful to your environment. It could be anything, okay? Whichever is like, the intent is malicious, right? So, now, what happens? This traffic, if it goes through your legacy firewall, this would be allowed because what we are looking at is just port 53, right? And it says port 53. That means it's a DNS traffic. Legacy firewall is not going to be able to understand what actually is the traffic, right? What actually is the payload, right? So, what NGFW does is NGFW is gonna run app ID, right? App ID is an engine that has those signatures, algorithms, patterns, everything inbuilt into it, right? And at the same time, there is a feature nowadays, like we have an app cloud engine, right? Wherein those IDs are there on the cloud as well. But again, that might be a topic for a different session, right? So as of now, app ID, whenever a traffic reaches the NGFW, it's definitely going to check the port, and it's going to check the layer 7 information. That will be your payload, right? And it's going to run that payload against the patterns or signatures and identify what kind of application is this. Okay. Now, if you see a traffic on port 53, but the payload is not matching, right? Payload is not matching. And then it will try to identify it. Okay. What is actual traffic? And it will be able to identify based on this patterns, right? And then if the application is something else, right? Let's say here it's let's say spyware. Okay. It's some sort of spyware. Okay. And we do not have a rule to allow spyware, right? Definitely. We just had a rule to allow DNS. So what will happen? This traffic is gonna go ahead and match into zone, deny, and get dropped, right? Right. So this is where the application intelligence comes into picture, right? And again, we are not talking about the content inspection part as of now. I am just giving you an example of app ID. Definitely, there is much more to this, right? App ID is being done, and after that, application is identified, then it goes to content inspection engine, and a lot more things happen in the background. I'm just trying to simplify it for you guys, right? So, just based on the applications, how this entire thing works. So that's it, right? The packet will be dropped if the payload is not what exactly we have mentioned in the application part. Okay. Uh, Cool. Let's have a look at our lab. Let's go ahead and see a few things over there. Uh, Let me close this. All right. So, guys, I have created a new lab. This is lab 4, right? Wherein you'll be able to resume your work from whatever was done on your lab tree, right? So you'll be able to click on import config, and then you have this import option. And okay, it already has some config. You'll go ahead, you'll wipe it. Yes. And then import. So it will have the configurations like whatever we have done in our last class, like interface management, profile, and those security rules, NAT rules, right? Whatever we tried to configure. Hmm? Uh, cool. This is imported. I'll go ahead and start these machines. I'll start one LAN machine for now, and just one ISP router. These we'll discuss when we'll start with the CMP. Right now, I have modified the topology to include a second ISP router. Generally, this is a dual ISP uh, scenario. We'll discuss about this, right? Just these machines are booting up. Mm, all right. So this is my management PC. Password is welcome. Again, the credentials are same. I have not changed anything. You'll be able to log in the same way you used to do after import, right? And the passwords, everything is mentioned over here. Cool. Let's see if the IP address is assigned. Let's get it from here. So 192.168.1.2, and my firewall's IP address is 192.168.1.1, right? So nothing changed over here. Let's see if it's accessible. 192.168.1.1. I guess it might be booting up still. Let's see. So we got a login prompt, I guess. It should be up in a minute. It's reachable, so it will take a minute maybe to come up. There we go. So we have nothing to do from CLI. I'll go ahead and close this one. It's taking some time. Let's allow it a couple of more minutes. Admin, the password is test at 123. Okay, let's log in again. Test at 123. Okay. Generally, the first boot, it takes a bit of time because your browser will try to cache. Not many things happen, so I'll request you guys to be a bit patient with this, right? But yeah, after second or third attempt, things it will not take this much time. Okay, there we go. Uh, so let me show you what all application IDs are there in Palo Alto, right? So you need to navigate to objects. Once you navigate to objects, you'll be able to see something called as applications. Okay. You'll be able to see a list of applications that is there in the database of Palo Alto, right? This is app ID database based on, I guess right now you can see 4,261 over here, right? So you have database wherein 4,200 application signatures are defined as of now. The cloud-based app ID has a lot more database as of now. That might not be the use case for a firewall, right? So you'll be able to filter over here. So you see category business systems is having like 1,500 application IDs defined. And then subcategories over here has audio streaming and so there are a lot of subcategories that you can go ahead and filter your applications. You have uh, something called as risk. This risk gives you sort of like the risk rating for that particular application. If that application is evasive in nature, if that application is uh, maybe having something that has been identified earlier for behaving abnormal, right? So based on this, these risk ratings are calculated, right? You'll be able to again do a tag. You can see something DLP exclusions. These are used in DLP rules, wherein you create a rule to uh, allow certain traffic, right? From DLP engine. Okay, so again, not going to go into deep onto these. The characteristics are specified over here. For example, FedRAMP is again a standard. HIPAA is where it's a health information protection uh, and act, right? That protects health information of their customers, right? These are generally applicable in Europe and these countries. Data breaches, evasive, right? And these are the characteristics of the application. So, for example, now you want to search about a particular application. Let's go ahead and search for Zoom. Do we have Zoom? Yes, we have Zoom, right? So you can see the applications over here. Zoom again. So Zoom is the parent application. You can see there are sub applications, right? Zoom base, Zoom downloading, Zoom meeting, Zoom phone, and Zoom sharing, Zoom uploading, right? So these many applications are there based on, for example, so Zoom base is the Zoom application itself, right? Zoom downloading is wherein if you are trying to download a file from Zoom, right? So generally a chat has an option where you'll be able to send some files as well if you are downloading something from that. Zoom meeting, right? If there is a meeting that is being scheduled right now, like we are in our meeting. uh, then Zoom phone, Zoom sharing, right? So these are sub apps, part of a bigger app or a parent application, right? So you can see the category for Zoom is SaaS, that is software as a service, right? And then file sharing subcategories are like file sharing, general business, internet conferencing, office programs, and then the risk rating is 1, 2, 3. For file sharing, it says risk rating is 1. General business, its risk rating is uh, 2, right? Uh, so you can go ahead and have a look at the application IDs. Now, generally, I have been asked this question, like, uh, one of the customer asked me that, can you tell me if this particular application is supported or not by Palo Alto? And again, I was not in front of my system, or I did not have access to my Palo Alto firewall. How can I go ahead and tell him then there itself, right? So we have something called as Applipedia, which is publicly available. You can just go ahead and open applipedia.paloaltonetworks.com, right? And you will have the exact same database over here, and you'll be able to do the search. You can see there's a minor difference, 4419. Some of the application IDs have been added. You can go ahead and do your search over here. Again, you can do the Zoom. You'll be able to see Zoom, right? So Zoom uploading, downloading, page, phone sharing, meeting, right? So you can go ahead and click on these. It will give you the information about the app identity. The app ID identifies the uploading activity of the Zoom, right? And then you'll be able to see the dependencies. This application depends on Zoom base, right? So Zoom base is the base application, where Zoom itself, right? And then inside Zoom, you'll be able to do your uploading or downloading, whatever, right? The characteristics, right? So the category is SaaS, subcategory is file sharing. You can see the risk rating. You can see the ports that this application is going to use. That is TCP 8443, and again, the technology is client server. These are the SaaS characteristics, wherein certifications like HIPAA, PCI, SOC 2. So PCI is the payment card industry standard. SOC 2 is for SOC, and then HIPAA is, again, as I already informed, for health information protection, right? Uh, IP-based restrictions, yes. So you'll be able to get entire information about that particular application supported by Palo Alto Networks, right? So how Palo Alto Networks is going to see the ports and everything. You'll be able to see their other characteristics, like if evasive in nature, no bandwidth, and all this information. Cool. Let's get. I think I went in the flow, and no worries. Let's get back to our main topic. So what we'll do right now, we have this machine over here. This is booted up. What we'll do, we would like to block Facebook for this and allow rest of the traffic. Okay, let's see if we are able to access Facebook or not in the first place. Guys, I'll answer your questions towards the end of the session, like we always do, right? So let's see if we are able to reach facebook.com. No internet. Okay. I guess the IP address is not assigned. Let's check. Properties. Yeah. So let's go ahead and assign the IP address 172.16.1.2, and then subnet mask is /24, 855, and then the default gateway is 172.16.1.1, which is your firewall, right? Cool. And then we want the DNS servers as public DNS servers, that is 8.8.8. Click on OK. Uh, Done. So let's close. Close. Let's see, now we are able to reach it. Right? You can see Facebook is reachable. We are able to open Facebook. We are able to reach Google. We are able to reach, let's say, Twitter. So yeah, Twitter is working as well. Okay. Now what I want to do is I want to block Facebook. Okay. So let's go ahead and do that. And again, Facebook is blocked, but rest of everything should work. Twitter.com, uh, YouTube.com. I don't know. There's something wrong with Twitter, I guess. Gmail.com, CNN.com. Let's see. I'm just trying to verify everything is opening or not. I think there's something wrong with Twitter. This is weird. Not really sure. Not gonna open this. Not secure, right? Something's wrong. Uh, YouTube is opening. Gmail is opening. CNN.com is still. Let me do an HTTPS. So the reason I'm just opening these many tabs is to understand what all things are working as of now, right? Uh, I don't know, there's something wrong when we are trying to, yeah, this is mm, not sure. Download.com. Okay, something's wrong with the clock. Let me, Saturday, April 6, 9:43. Mm, Time zone is correct. Let me change that into time to, okay. So things are working over here. Okay. Uh, I think there is some issue with the time synchronization over there on the Chrome. I'll fix it offline. Okay. So we can see Twitter is working, Wikipedia is working, Reddit is working, right? Things are working. Uh, let's go ahead and block Facebook as we decided. This is my machine. I'll go ahead to policies. So the NAT rule is already there. You know, natting the traffic which is coming from, okay, right now it's set to static. Let's go ahead and change it to DIPP, because if we have to use my second machine, that might not work, right? So I'll go ahead and change that to DIPP, and I'll NAT it to the interface IP, and then 1/1. And in the original packet, I'll select it as any. Let me go ahead and delete this. This should be okay. We'll commit it after we create the security policy. So in the security rule, what we're going to do, we're going to create a new rule, add. We're going to name it block Facebook. Okay. We're going to give the source as trust and destination as untrust. Now we come down to application. Here we see application is set to any. So right now, any application is allowed in the environment. We'll go ahead and add Facebook. You can see Facebook is here. It depends on a lot of application, right? So you need to click on this and add to existing rule. Sorry, add to current rule, right? So what happens is, for example, this facebook.com, there are some other protocols that will run for this facebook.com to work properly. Okay. So for example, RTP base, SSL, stun, web browsing, WebSocket, right? These are the applications on which the Facebook application depends. Okay. So generally it's a good idea to add the dependencies as well, so that we are blocking everything, right? Uh, but as of now, these sub applications might be used by some other application as well, right? So I'm not going to block this because it's going to match SSL as well, and rest of the traffic is SSL, right? So I cannot go ahead and block it as of now. Okay, so we are just blocking facebook.com. Service URL, again, I'm going to keep this as application default because the port is going to come on. We'll discuss about the questions, guys. Okay. Yeah. So service, again, this is the port number, right? It's going to use 443, right? So I'm going to keep this as application default, and nothing in the URL category. We'll go ahead and action. We are going to block this, right? So I'm going to do a deny, and that should be it. Click on OK. Now you can see the rule that I created is on the second rule, right? And there is a rule that says allow internet. Now, every time user is trying to access Facebook, this rule will take a hit and the user will be able to access the Facebook, right? So I don't want that. I want my Facebook to be blocked. Rest everything should be allowed. So what I'll do, I'll just drag it and drop it. Right now you can see block Facebook is at rule 1 and allow internet is at the second number, correct? You can also do that from here, this option, move up, move down, yeah, move bottom, move top, right? So there are multiple ways you can do this. You can either drag and drop, or you can just select that rule and then click on move up and down, right? Either ways, it's going to be fine, right? uh, let's review this rule before we do the commit. Block Facebook any traffic originating from trust heading towards untrust, and the application that we have selected is Facebook on the default ports, and the action is deny. Okay, let's go ahead and commit. It'll take a minute for the commit to go through. Okay, almost done. Okay, so we can see the configuration committed successfully. Let's go ahead and test this. Okay, so this is my Windows machine, Win2, right? This is Win2. Uh, let's try to open facebook.com. You can see it says the connection was reset, right? The connection to the server was reset while the page was loading. Uh, can I open other pages? Let me see. Wikipedia. Yeah, Wikipedia is still accessible. Amazon, still accessible. Facebook, nope, Facebook is not working, right? Because it says the server was reset, right? Why this would be reset? Why this was reset, right? Let's have a look at the traffic logs, right? Let's see what actually happened. You can see Facebook base, right? Let me open this. This traffic is getting denied. Let me open this so that we can have a detailed view. Okay. All right. So we can see the action is reset both, right? Reset both in the sense what? Send a reset to client and send a reset to server. So the server knows that server thinks that this reset is received from what? Client. And the client thinks that this reset is received from the server, right? So because the action was set to deny, you see reset both as the action that was taken on this traffic. The application is what? Facebook based. The rule that is taking a hit is block Facebook. So now when we try to access facebook.com, we are taking a hit at what? Block Facebook rule. But you have allow internet that will allow rest of your traffic, right? And the session and reason, it says clearly policy deny. And you'll be able to see the natting and all those traffic going through as so natting and everything is happening as it should. But the moment it checks for a policy, if there is a policy that would allow this flow, it says deny. There is a policy that has been explicitly configured to deny this flow, right? uh, you can see other parameters if you like. You'll be able to get the information: app category, SaaS, social networking, and then browser based. And we were trying to access it on Firefox, right? So browser based. uh, then these are the characteristics. This is the app container, Facebook, and this is the app risk, right? So you'll be able to get a lot more information that might not be uh, important to you right now, but when you work in a production environment, these information might make more sense as it what category this application belongs to, what is the risk rating, if you like to block it or allow it, right? But cool. So this I guess gives you a good idea as to what application uh, app IDs, right? How you can block or allow a particular application, and so if you're blocking a particular application, you'll be able to allow rest of the application, right? Uh, there was a question that said messenger.facebook.com. Let's see if that opens, okay? So apparently it's not there. Okay, there is no such website. No problem. Cool. Let's go ahead and see the application filter now. So in the topics list, app ID. This is about app ID cleared. This is done. Let's talk about application filter now. Okay. So if you go again to objects, you'll be able to see something called as application group and then application filters. Right. Why do we use application filter? Okay. Application filter is used. For example, today, let's say there are 10 applications that belong to social networking category, right? And tomorrow there is a new application that is released, and we are adding that to social networking category, right? And in your environment, you want social networking categories to be blocked, but you don't want to do that manual job, right? Every time there is a new application released for social networking, you are going and then you'll have to add that to your rule, and it becomes tedious, and then it requires a manual effort to see, okay, has there been a change or not, right? So a simpler way to do this is to create an application filter. Okay. Go ahead and click on add. You'll be able to see your applications listed out over here, right? And then you can give it any name. So I would like to say block social media. Okay. Or social networking, whatever you'd like to give the name. The name is not a concern because this name is just going to be referenced in your security rule. Okay. And what kind of applications that we are looking to block, right? Let's see what we can block. Do we see social networking? Yeah, we see social networking over here. Okay, so let's select this social networking and let's click on OK. So there are multiple applications. If you'd like to manually go ahead and select, it's up to you. I'll click OK because I want to block this social networking completely, right? So you see, this subcategory is social networking. Whenever there will be an application and the subcategory is matching to social networking, you'll be able to block it. You can see the parameters, for example, location, category, risk, tag, characteristics. You can, create a filter based on all these parameters. If I go back over here, so Right now, I selected an option in subcategory. If you don't want to select in subcategory, you can go ahead and select in the category, right? It's completely customizable as per your need. You have, let me uncheck. You can clear filters. You have all these category. So if I select general internet, right? General internet is very broad, wherein you can see file sharing, internet utility. This will cover a lot of applications, and I don't want to block all of these, right? uh, Collaboration is going to have a lot of applications, and for example, it has social networking, but again it has other things as well, like internet utility, social business. I don't want all this to be blocked, right? So what I can do, I can just select a subcategory because that is what I need at this point in time. If you want to block a whole of SaaS domain, you can do that, but a lot of applications might not be accessible. Or you can manually select applications. You can select, for example, I would like to block Zoom and Skype only, but that defeats the purpose of having an application filter altogether. Okay. So let's go ahead and stick to our social networking. Yeah, there we go. Cool. I'll click on OK. And so I have created this filter. Now, what do I do with that filter? Let's go ahead to the policy. Go to the application. You see my application filter over here, block social media. I'll select that. Okay. And then I can remove this Facebook. Definitely Facebook is also a part of social media subcategory. Okay. So I selected this. Let's go ahead and click on OK. The action is still, we can see deny, right? And the only change that I've done is instead of application, I have added an application filter over here. Click on OK. Let's click on commit. Commit. So tomorrow, if a new application is released, for example, any of you start a startup and create a social networking app, right? And then PaloAlto defines a signature for that. And if I have to block social networking only, I'll just use that filter wherein the subcategory will be social networking and that particular application will be blocked, right? So I don't have to go ahead and manually add new applications which are there with a subcategory of social networking. Okay. So this simplifies your day-to-day activities as an administrator, wherein less manual work and sort of like a bit of automation over there, right? Let's wait for this commit to go through and we'll then test if things are working or not. Time of log looks different. The time of log looks different. The reason for that is the firewall. Okay. So if you see, the time over here on the firewall is Friday, April 5, 21:31, right? And this is the uptime. The reason this looks different is I have not set the time zone, right? We can do that. I mean, in our earlier classes, I've shown that, but you can go ahead and change the management settings over here, right? Let me change this. So if you come down here, so you can set the date and time, right? And the time zone. So based on this, your firewall will also be at the same time zone as your machines, or generally, we keep the time zone as where the firewall, wherever the firewall is placed, right? Now, generally, firewall might be able to handle a lot of traffic coming from different places, right? It could be a different country as well. So, but yeah, you can go ahead and set this time. So I'm not bothered about this as of now, but yeah. But rest assured, that is the traffic that we were uh, looking at. Okay, cool. No worries. Let's go ahead and see if we are able to. Yeah. So we see the commit is completed. This is done. Let's close this. Let's go to the machine. I'll close this. Okay. Let's see if I'm able to access Google, right? That is the google.com. My bad. Right. So google.com is accessible. Gmail.com is accessible. YouTube.com is accessible. Let's see. So YouTube is accessible. Gmail is working, right? Now let's see some social networking sites. I guess Twitter should be social networking as well. Let's see. Let's open Applepedia so that we understand. Follow. You can see Twitter failed to load, right? Let me close these tabs. We'll work on the tabs that we are trying to work on, right? So if we see, let's see what is Twitter. I mean, what is the subcategory? Because we are blocking the subcategory, right? Where is Twitter? Twitter, right? Let's click on that. Uh, Twitter base. So we can see the subcategory social networking. And when we try to access the Twitter page, it got blocked, right? Let's try Facebook again. And Facebook is also not loading, right? Let me see if what all applications are there in sub category of social networking. Okay, so let me clear this. Let's filter on social networking. Okay, so we already checked Facebook. I don't want to check anything that I'm not familiar with. Okay. Reason being, we don't know what kind of content is being displayed. Okay. I think it's not displaying it quickly. Browser based. MySpace. Okay. Let's check MySpace. Have I opened it correctly? MySpace posting, MySpace base. We're still in the loading part. Orkut, right? Orkut. One that is no longer uh, or long forgotten. Let's see Orkut if it is opening. This opens some of the block, I guess. Orkut. Yeah, I guess it no longer is in service, so maybe that's the reason. You can see it's still trying to load, not able to open that, right? Uh, Quora, let's see if that works. The connection was reset, right? So again, if you'd like, we can go ahead and check on the firewall. Let's see the logs over here. You can see MySpace base is denied, right? You'll be able to see over here, block Facebook is the rule that is taking a hit. This is deny, right? So that's the reason that is showing that it's trying to load, because there might be multiple connection attempt that might be going on. So some of the websites, even if there is a reset, they try to reattempt it. You can see it says performing a TLS handshake, right? And where it's getting dropped. Uh, so MySpace is not opening as well. This is getting denied. Uh, Quora base, this is the Quora application that we try to open. This is getting denied, right? You'll be able to see. Let me open this so that you have a bigger view. This might be a bit smaller. All right. Uh, So we can see the action that is taken is reset both, right? And the application is Quora base. The rule that is taking a hit is block Facebook. Okay. And in the block Facebook, we have added an application filter, right? The session end reason is policy deny because this policy explicitly says that deny to traffic. And remaining parameters remain the same, whatever source and destination is, and whatever the NAT we are doing over here for source translation, right? You'll be able to see subcategory as social networking, and this is browser based, and this is how we blocked it, right? uh, so I think this is sorted. I think application filter is covered. I'll definitely take. I'm pretty sure there might be questions. We'll take those questions towards the end of the session. Okay, let's continue with our discussion further. So as I mentioned, I'll try to cover this in our next class. Let's talk about these two features right now: ECMP and policy based routing. Okay. So, what is ECMP and why we may want to use that? Let's go to our whiteboard. I'll close these tabs. Cool. Let's go to this. All right. So, what is ECMP? ECMP means equal cost multiple paths, right? That means what? There is a particular destination. So, I'll take a router's topology over here. Okay. And this particular router, let's say this is your LAN. This is your Windows machine, okay, connected to your router. This might be a perimeter router. I'm least bothered about the topology. I'm more concerned about the, uh, how we are gonna discuss the traffic, okay? So let's say, and this is my server, which is hosted on internet. Sorry about that. So this is my server. This is hosted on internet. Okay. Now this router again is connected to ISP router 1, ISP router 2, ISP router 3, right? And these have connectivity to the server. These have connectivity to the server. These have connectivity to the server. This is internet. Okay. This will be my ISP R1, R2, and R3. And these are different ISPs. Okay. So this could be Airtel. This could be maybe any BSNL or dedicated lease line, and this could be an MPLS or whatever, okay, just for the sake of understanding. Now you have three routers. First question, why do we have three ISPs in place, right? Why do you need this? So what happens, enterprise is huge, right? The environment is huge. They have thousands of users reaching out to internet or reaching out to their services that might be hosted on the cloud, SaaS applications that might need them to access the internet. Now, because if the internet is down, that might impact their business. The uh, production team might not be able to do their job, right? So what generally happens is they will have one instead of one ISP, they'll have two ISPs, right? And wherein if one ISP goes down, you still have a second ISP to reach out to the internet so that your business is not impacted. In our case, I have taken an example of three ISPs, right? Just to explain the concept of ECMP. Now, equal cost multiple path, that means there is a destination. So this is my destination, right? And in order to reach that destination, so this is my source and this is my destination. Okay. In order to reach a destination, there are multiple paths available. Okay. Multiple paths. This is path one, this is path two, and this is path three. All the three paths will be able to reach to the same destination, right? So now, in a general concept of routing, what happens is if you have multiple routes, the router, what it will do, there will be a routing algorithm. It could be OSPF, BGP, whatever, right? That will go ahead and select one best route and will install in fib. The fib will have one route only, right? Fib is forwarding information base, right? And rib is routing information base. Rib is where it has all the routes that is available, and fib is where the forwarding information base, which is actually used by your router or the firewall for that matter, to forward the packet, right? Now fib will always have one route or one entry for a particular destination in our routing table. Okay, sorry, in our forwarding table. Okay. Now, but we have multiple links, and what is happening is this BSNL link. So let's say this is my primary ISP, and I have a default route saying every traffic should go through the Airtel router. Okay. Now that's good. Airtel is being used, but what happens? And whenever there is a failover, the traffic will be shifted to BSNL. That's okay, but as long as Airtel is up, we are not using BSNL, and that link is just lying there. It's not being utilized, right? So it's underutilized. We are paying for it. We don't want the bandwidth to be wasted, and we see heavy load on Airtel. So Airtel is doing all the heavy lifting. BSNL is just sitting and enjoying, right? So what we can do, and again, then there is this link, right, which is over there. But again, we are not using this as well. So what we can do, we can enable ECMP. Now, what ECMP does is it installs all the possible route. So it will have like route one, route two, and route three. All of these routes will be installed in your fib. Okay. And then we will define an algorithm. Okay. So we will define an algorithm. That algorithm will decide how the traffic is being sent to route 1, route 2, and route 3, right? A general or the most common one that everyone is aware of is round robin, right? Round robin is first packet goes to route 1, second packet goes to route 2, third packet goes through route 3. Okay, because apparently the important thing is to reach to the server, right? It's okay whatever path you might take. So route one, route two, route three, this can be based on the round robin. When you are done with route three, you'll again start from route one, route two, and route three. This goes on. This is what is called as round robin. So you define an algorithm, and based on these, the packets will be sent from all of these links, right? Instead of sending it through just the Airtel or the primary ISP. This is how you are going to utilize the bandwidth or the link for other ISPs as well. Okay. There might be other use cases. I'm just taking this use case because this is simple to understand. There might be different use cases. The traffic could be internally ECMP'd, right? This is also, you can call it as load balancing, right? So instead of giving all the load to Airtel ISP, we are sharing the load or load balancing it to BSNL and other router tree, which might be an MPLS or any other link for that matter. Okay. So, and the point is the destination should be the same that we are able to reach out to there. Okay. Now, when it comes to PaloAlto, there are certain limitations though. You cannot have like hundreds of route. We can have 4 routes at the max. Okay, so that is the limitation. By default, 2 would be selected. This is the default value. Okay. Uh, all right. So this is how your ECMP generally works. Okay. Your fib will have all the route entries, and we'll see. Let's go ahead and do that in the lab. All right. Let's come here. So again, this is a routing concept or a networking concept, less of a security concept, but this capability is there on the firewall. So we are discussing this. Okay. Uh, you need to navigate to your virtual router. So as of now, okay, let's see the topology first. Okay, let's go to our topology. So what I have done in our topology is I have added 2 ISP routers. Okay, I don't have 3. I can do that, but again, there's no merit on having three or four, right? It's going to be the same. So let me start this router. Again, as this ISP router, the config for this ISP router is already done. You don't have to go ahead and do anything on this particular router. Both of them have access to the internet. We already have a 10.1.1.0/24 segment on primary, or this is our ISP router 1. On the ISP router 2, I have defined the 12.1.1.0 segment, okay, wherein the firewall is having a .2 IP address, that is 12.1.1.2, and the ISP router is having 12.1.1.1, okay. Now, because they are reaching out to the internet, we are going to go ahead and define two default routes for the internet, right? And then we are going to do a load balancing between the primary and the secondary, first or the second link. I'm not going to say primary and secondary. Generally, primary means it comes into high availability, where whenever the primary goes down, the secondary comes into picture. As of now, we will say these two links will have a same destination, that is the internet. Okay, so we'll go ahead and let's have a look at the GUI. I hope the topology is clear. Let's go to the GUI. Okay, you can see I have added this on my Ethernet 1/2 interface, this ISP router, and we have to assign this IP address. I have not assigned any IP address yet. I'll go ahead and assign it right now. Okay. Let's make this layer 3. Okay, virtual router is going to be default. This is, again, I'm adding this to untrust. We have discussed this, that multiple interfaces can be in the same zone. Like 1/1 is already in my untrust zone. This is, I'm adding 1/2 as well in my untrust zone. But one interface cannot be in two different zones. Like 1/2 is in untrust and trust, both of the zones. That is not possible. Okay. So security zone untrust, IPv4. I'll go ahead and add the IP address 12.1.1.2/24. Again, this is untrust interface. I don't want to add any management profile over here. We'll click on OK. Okay. And let's do a commit so that this interface comes up, and then we'll proceed further. Allow it a minute while this commits. We can see the IP address that is already assigned to this router is 12.1.1.1. Okay. Close this. Now, the first thing that I'd like to validate is whether I'm able to reach out to the internet from 1/2 or not. Okay. For that, we'll have to add a default route. Cool. Let's close this. We can see my interface is up. IP address 12.1.1.2/24. Let's add a second default route. Go to the static route. Click on add. We'll give it a name, default route 2. The destination is internet, so 0.0.0.0/0. It should go through the interface 1/2, not 1/1, right? 1/1 is already configured. And the next hop IP address is going to be 12.1.1.1. And if you see, I'm not changing any admin distance, metric, anything. This is going to be exactly the same. Let's click on OK. Now I have added this default route. Let's see, click on OK. And if we'll try to commit this. Let's wait for this commit to be completed. Oh, what does it say? It says failed, right? Now, why does it fail? In virtual router default, the static route default route to metric value 10 is not unique, right? That means we already have a static route which is pointing to this particular destination, which is 000/0. When we add a second route to the same destination, it says that is not possible because there is already a route which is existing. Okay. Now, in order for this to go through, what do we need to do? We need to go ahead and enable ECMP, right? Because based on ECMP, you'll be able to add the routes. Okay. Let me. So, router settings, ECMP, you'll click on enable. Okay. Once you click on enable, you'll be able to see there are a few other options. Okay. Uh, you see the max path over here. We already discussed the default value is 2. As of now, I just have 2 interfaces. That's okay. You can add, make this maximum to 4. You cannot have like 6 or 8, anything over here. You can max that is supported by PaloAlto is 4. Okay. Now, symmetric return, what does that mean? That symmetric return is actually applicable to a flow which is initiated by the server, right? So any traffic coming from your server side going to your client, and then when the client responds back, it should go through the same interface on which the packet was received. Okay, let me explain this bit in a whiteboard. Okay. So if this is your router, for example, and these are multiple paths, okay, and this is my server. Now, let's say this is my client machine, for example, okay. Now, let's say this server sent a packet through this link, or the packet was received on this particular interface, right? So in that case, when the client is replying back, you want it to go through the same link. Okay, you don't want to go the reply. You don't want the reply to go through this particular link, right? Or any other link. In that case, what we try to enforce symmetric return, right? But generally, this is applicable for the packets which are incoming inbound traffic, not for the outbound traffic. We're not going to enable this. We're not going to go and do the strict source path and all that as of now. Uh, Load balancing, this is where you select the algorithm, what algorithm you'd like to go ahead and use for the load balancing. So you see, we have something called as balanced round robin. I talked about round robin, but what is balanced round robin? Okay. Balanced round robin, for example, you had 4 links earlier, and there was a round robin happening, link 1, then link 2, link 3, and then link 4, right? What happens if one of the links is removed? One of the link is removed, then the round robin is going to happen. The balancing is going to happen between remaining 3, 1, 2, 3, and then back to 1, right? So that is why it is called as balanced round robin. Okay. We have IP modulo, IP hash, and then we have weighted round robin, and we have balanced round robin. let's see what is weighted round robin. We just talked about balanced round robin. Let's check weighted round robin. Now, in weighted round robin, what do we do is we add the interfaces over here. So let's say my two interfaces are Ethernet 1/1 and 1/2, which are gonna be enabled for ECMP. Here, I assign a weight. For example, let's say the weight for Ethernet 1/1 is 100, and for this is 50. Now, what happens if I go ahead and commit this? The weight make sure uh, you know more load. I'll not give the statistics as of now, but maximum it will try to put that traffic on Ethernet 1/1, and after that, so for example, let's say there are first packet to Ethernet 1/1, second packet to Ethernet 1/1, third packet to Ethernet 1/1, and fourth packet to Ethernet 1/1. Then fifth packet is gonna go to 1/2, sixth packet is gonna go to 1/2, and then again back to seventh packet 1/1, eighth packet 1/1, ninth packet 1/1. So we are assigning a weight. More the weight, the more number of sessions or packets are going to be handled by that particular interface. Even though it is a round robin, but based on the weight, we are going to assign more packets, or we are going to send more packets through that interface than the interface which is having a less weight. So this is your weighted round robin. Okay. If we go ahead and talk about IP hash, here when you select this IP hash, you'll have few options like use source address only or use source destination ports. What we are doing is we are doing, for example, let's say, okay, let me go to the whiteboard. That makes it simpler. Okay. Now, if this is my client machine 1, client machine 2, client machine 3, right? Machine 1, 2, and 3. And this has an IP address of 172.16.1.2. This is 1.3. This is 1.4. Okay. And then all of these are connected to a switch, and that switch is connected to a PA firewall, and then they have these. I'll just draw two because that is right. Router 1, router 2. This is R1, this is R2. Okay. Now, I always want 1.2 should always go through router 1. Okay. And 1.3 should always go through router 2. How this can happen is you can do a hash calculation of your source IP. So for example, my current IP address for this machine is 172.16.1.2, right? What I'll do, I'll put it through a hash function. I'll calculate a hash, and based on that hash, that particular hash will be always taking the R1. Okay, so this is my hash 1, and then there will be a hash 2 that is always taking the route 2. Then there is a hash of this IP address, and that will always be taking your R1. So generally what happens is, based on, let's say that you have two links, based on that, the hashes will always make sure that the packet is always traveling through the same link, right? So I always want this machine to go through R1 all the time. Then I'm going to go ahead and select the I'm going to go ahead and select the IP hash. Okay. And I'm going to select use source address only, where we are going to do the hashing of source address. We are not going to hash anything else, just the source address. If you select both of these, then what it's going to do is going to do source address, and at the same time, it's going to do source and destination ports. Okay. So it's going to take into the, but what happens is source, and if you go ahead and check this option, this will randomize it. How? So right now we are just doing the IP address hash. It will always be the same. No matter how many packets I send, the packets arrive at PaloAlto firewall. It's going to do the hash of IP address, and the hash is going to be exactly same all the time. And based on that, it will always forward that through router 1. But now if I add maybe a source port and destination port, right? Let's say source port could be 65,000. Now let's say I add a source port of 65,000 and destination port of, let's say, 443, right? Now we add this to the hash. What will happen? The hash will change. Then it might be sent through router 2. Then again, there is a new application that you open on your Windows machine. The source port will definitely change. 65,000, then you might have 65,001. So that 65,001 when it comes to the firewall, it will compute the hash. That hash will again change. So hash function is whenever you give an input, and if the input remains the same, the output, you'll always get the exact same output. The moment your input changes even slightly, the hash is going to change, right? So whenever there is a source port change, you're going to see the hash will change. And then again, when the hash will change, it will be sent to a different link than the link that it was sent earlier, right? So this is how you can use the IP hash algorithm, right? This method, IP hash algorithm, and it will either do the source address only, or you can use the ports as well. Okay. Hash sheet is, again, you can add a numeric value to randomize it. If you want it to be randomized, right? If you don't want a particular link to be uh, utilized all the time, and you have multiple links, like 4 links, right? And you want to randomize the packet flow, right? In that case, you can add any numeric value. It could be like 1, 10,000, 50,000, or any numeric value over here. And that numeric value will also be taken into consideration when we are doing the hash. Okay. Now, the last one is IP modulo. IP modulo is again an algorithm that does a modulus operation on your source and destination IP addresses, and based on that, it will determine which link to take for the egress. Okay. So these are the algorithms that are available that you can select for the load balancing between all these links. Okay. For now, for simplicity, we'll go ahead and select balanced round robin. You can play around with this in your lab. Uh, you can go ahead and select IP hash. You can select IP modulo, weighted round robin. Already explained, for weighted round robin, you need to assign weights to that particular interface. Which one, whichever of those interfaces is going to do the heavy lifting for you, right? So right now, let's go ahead and check balanced round robin. Let's click on OK. So it will give you a warning where it says enabling, disabling ECMP and configuration changes require a virtual router restart. Existing sessions may be impacted. So please be careful when you do this in your production environment, because what it will do, it will reset the VR. If VR is restarted, that means your interfaces, your static routes and your routing protocols, everything will be restarted, right? So that might impact your routing and your packets might be dropped. So I want to continue, click on yes. And let's go ahead and come. So I already have my static route added, right? Let's see if it is there or not. Static route, route 1, route 2. Okay. Click on OK. And let's do a commit. Let's see if the commit goes through this time. Okay, all right. So it's almost done. You can see now the commit is successful, right? Almost 98%. So hopefully this will go through, right? So now I believe you got the gist, right? That there cannot be two default routes or two static routes, not just default route, two static routes that you can configure for the same destination, right? So if you want to do that, you can go ahead and enable ECMP. I have done this through static route. It can be done through routing protocols as well, for OSPF or BGP or anything else if you'd like to do. But again, that might not be this straightforward, right? That might need a better understanding of the routing protocol and what routes are to be advertised from your other side, and then how many routes you'd like to have it over there. Okay. Click on close. So now we have ECMP in place. Okay. We'll go to the monitor and we'll add the egress interface. I'll remove this type. I'm not bothered about this type. Mm, Don't see that type. Uh, Here it is. I'll uncheck the type. And then I want egress interface, right? Because that is what we are interested in to see which T here it is, egress interface. Cool. So you see, these are the egress interface that you are able to see right now. Everything is going through 1/1. Okay. Let's go ahead and enable I'll also enable this machine. All right, let's start this. So right now we have selected balanced round robin. Okay, let's see what happens. Again, Facebook is blocked. So let's try other websites, Wikipedia. Let's try Reddit. Let's try YouTube, Applipedia. This has opened. So this is getting reset because again, the category for Reddit would be uh, social networking. I don't know about YouTube. We'll have to check that. You can check it here. Source, YouTube. Mm, where is YouTube base? What is the subcategory photo video? I'm not sure why that was blocked. We can check it that later. Let's try to find some more, for example, Amazon. Amazon.com. Uh, News.com. So Amazon is opening. So not fine. Let's see if download.com. Times of India. So download.com is opening. So I'm just trying to generate enough traffic, right? So we'll be able to see the behavior. Okay. So these are the websites that are opening up. We were able to see that we are able to browse this. Okay. Let's go ahead and check on the firewall. We'll come to the monitor traffic logs, do a refresh. You can see the interfaces are different. Ethernet 1/1. Then you see Ethernet 1/2, right? Uh, you might be able to see that it is taking Ethernet 1/1 for a couple of flows. That might be because you know the destination might be the same, right? Over here, you can see Ethernet 1/2, Ethernet 1/2, going through Ethernet 1/2, and then Ethernet 1/1, Ethernet 1/1, right? So it's sort of like doing a round robin, wherein some of the traffic is going to go through your 1/1 and then 1/2 and then 1/1. So you can see 1/2. Let me see if I can make it 100. Right? 1/2, 1/1, 1/1, 1/2, 1/2, 1/1, 1/1, 1/1, 1/1, and then 1/2, 1/2, right? So whatever, how many amount of packet is being sent through one interface, the exact same amount of packets will be sent through another interface, and we are doing that on a round robin fashion. Okay, so this is again balanced round robin right now, not an exact round robin, balanced round robin. All right. So this is how you go ahead and do your ECMP, right? If you'd like to see few more details about ECMP, what you can do, you can come down to your virtual router under network tab, and you'll be able to see more runtime stats. Once you click on that, under routing, you'll be able to see route table, forwarding table. So this is your rib and this is your fib. Okay. So in the rib routing table, you'll be able to see there are two destinations, 000 and 000, right? Both of them are to the internet. The next hop is 10.1.1.1 and 12.1.1.1.1. So you see the flag over here. It has E at the last, right? That E is to resemble that it is ECMP. Okay, when you see E, this flag is added to represent the ECMP. Okay, what are these flags? You can see over here: A is active, C is connect, H is host, static. You'll be able to see all the information over here. Okay, so S is static, A is active, and E is ECMP. If we can maximize it, you'll be able to see, I guess. Let me see. Yeah. Right? So you see E is ECMP. Okay. So this is my routing table. Okay. Routing table is not the actual table that is being used by your firewall to forward the traffic. Routing table is wherein all the routes which are present on the firewall, right? And based on the routing protocols or the static route that we have defined. Let's go to the forwarding table. Now, in the forwarding table, you'll be able to see there are two routes which are installed for the same destination, and this has the flag of E. E, and then we have a star, which says the preferred path. But again, these two routes are there, and based on this, we'll be able to do the load balancing of the traffic over these links. Right now, I have added just two links. You can add up to four links and four destinations. Sorry, four static routes to the same destinations will take a hit, right? And we just validated from our traffic log that we are able to see the packets getting through 1/1 and 1/2 instead of just 1/1. Okay, cool. So this was about ECMP. Okay, there are multiple things that you can give it a try, change the algorithm, because if I go ahead and do that, it will take up too much of time, and we'll not be able to go through the topics that we have planned. Uh, let's go ahead and quickly talk about policy based routing. Okay. Uh, what is a PBF? We generally call it as PBF. In order to configure a PBF, you'll have to navigate to policies. So this is policy-based forwarding, right? So let's discuss first about PBF, and then we'll come here and configure this PBF. Okay. So let's go to the whiteboard. What is PBF? PBF is, as the name says, policy-based forwarding, right? What is PBF? Policy-based forwarding. right? Uh, what do we mean by that? We mean that we define a policy, and based on this policy, you will be able to forward the packet. But then the question arises, don't we have the routing for that? I mean, we already have defined a static route. Uh, should that static route not take care of it? So yes, the answer is yes. There is a routing in the environment that will take care of your routing the packets. But in certain cases, for example, for the same example, let's go back. Let's go back over here. Okay. So this diagram here, you see Airtel is the primary ISP and it has a bandwidth of 100 meg, just for an example. And BSNL is secondary ISP and it has a bandwidth of 50 meg. Okay. Now, what I want is this, BSNL uh, is being 50 meg. I don't want all the general traffic to go through BSNL, because if all the traffic goes through BSNL, what will happen to BSNL? BSNL, the link will be saturated and we might not be able to access our internet or whatever. The traffic might be down, right? So I don't want to saturate this link. So I want only the business critical application, or not business critical, but my uh, important applications to go through BSNL, and I want my general traffic to go through. This is a leased line, even though the bandwidth is 50 meg. Let's say this is a leased line. Okay, leased line has a better performance than your general broadband. Okay, so I want all my traffic, general traffic, to go through Airtel, and business important application to go through BSNL. Okay, in that case, what we will do, we will add a policy based routing, a policy based forwarding. We'll define a policy wherein you will define certain applications, right? Let's say general traffic, right? For general traffic, I'll say YouTube and Facebook. Sake of simplicity, okay? You can add any general traffic you want. This YouTube and Facebook should always go through Airtel. Okay, should always go through Airtel. So I define a policy wherein I say application YouTube and Facebook should always go through my Airtel link, and then rest should go through BSNL. So I don't need to define a second policy. Now what actually happens, how this works is, you need to understand the route lookup for that, right? So whenever a packet, let's say a packet is arriving to the firewall, right? If there is no PBF, if no PBF is defined, then your routing will take care of forwarding the packet, right? Forward packet. However, if you have a PBF, it takes precedence, right? What do I mean by that? If I have defined a PBF, my PBF will be evaluated first before the routing. And if a PBF takes a hit, then we are not going to go to the routing. So even though you might have a default route stating 0.0.0.0/0 should go through Ethernet 1/1, my PBF says forward YouTube traffic through Ethernet 1/2, right? It will take the hit for this one, PBF, right? So the PBF will take a hit, not the default route. Okay, because we have defined a PBF, and PBF takes precedence whenever we are, before we are trying to route the packet, right? How that packet will be sent out, the PBF will take a precedence, and then will come your routing. Okay, so in case a PBF is defined, and if a PBF matches and takes a hit, then that PBF will be evaluated, not your routing. It will never come into the picture. Okay, so this is what your policy based forwarding is. Let's go to the GUI and see how we can configure it and what all things are there in your PBF. Okay, let's come down to policy based forwarding. I'll click on add. You can give it a name like any other policy. I'll say, My YouTube is opening, right? Let me check that once again so that youtube.com. We'll check into this. No worries. For now, we can check Wikipedia, right? And then Amazon, right? So these things are working fine. So we can go ahead and add Wikipedia and Amazon in our PBF role. So I'll say uh, PBF, Amazon, Wikipedia. Okay. Uh, the same, there is a description box wherein you can add the description. What is this role about? Then you can tag it. Tags are used for organizing the rules. As of now, we just have one rule. There is no need for a tag. Audit comment, I have already informed you what audit comment is. Under the source, let's add trust. Okay. And I'm not adding any source address or any user again is not possible because that is a part of user ID. Then we go to the destination address or application, right? So I'm not going to add any destination address because this is public, right? So I'm just going to add application instead of destination address. So if I go here, let me see if Wikipedia is defined. Okay, I don't see Wikipedia. Let's see Amazon. Hmm, surprising. Let's see what all applications are defined. Okay. Hmm. Amazon. Amazon Prime Video. Are we able to open that? Amazon. Let's see if that's getting blocked. Okay. Because I see some of the applications are not accessible. Or let's relax our filter. Okay. Instead of application filter, let's go ahead and add application only. As of now, troubleshooting will take a bit of time. We are already on that 2 hour mark. Let me delete this. Add Facebook. That's what the rule says. Cool. Okay. Let me do a commit. Suppose meanwhile this is working. Let's go to the PBF and okay, let's see if, so we can see Amazon Prime Video is opening. Okay. So let's see if we are able to add that as an application. I'll give uh, PBF, Amazon, or let's say just Prime. Okay. Source is going to be your trust, destination any, and I'm going to try to add an application as Prime. Okay, let's see what all things are there now. For some reason, we are not able to see the applications over here. Just give me a minute, guys. This is surprising. Okay. For now, let's say McAfee. Let's see if you're able to open McAfee. I'll check on that, guys. Okay. In our next session, uh, why we are not able to see the applications. Definitely, I'm going to check into that. But generally, yes, it is visible, and yes, I've done that multiple times. But for now, I'm not able to see the applications are there for some reason. I'll check what's going on that. We'll still try to see if we are able to forward the McCafe traffic. Let me see if we are able to see that over here under the traffic logs. Fine. I think we can do one thing. We can see DNS base, right? So what we can do, we can force the DNS base through our second interface all the time, right? Let's do that. I think that would be the easiest one to see the PBF in place. In the next session, I'll definitely demonstrate this again to see if we are, we should be able to add these applications. Definitely. That is the whole purpose of PBF. Let's see DNS base. Okay. So uh, first and destination application. Let's see if we get DNS. Yeah, so we have DNS base over here, right? Let's select that, and we're going to forward it. So the action that you're going to get is forward, discard, or no PBF, right? So again, uh, use of no PBF is wherein you have certain set of applications defined, but for particular destination, you don't want that PBF to take a hit. So you define no PBF for that, right? And then you have an option to either forward the packet or discard the packet. So we're going to do a forward. The egress interface I'm going to do is 1/2 all the time. And the next hop is IP address. And the next hop for this one is 12.1.1.1, right? You can do a lot many things wherein you can monitor a particular destination, and if that destination goes down, you will be able to bring this PBF automatically removed from your firewall, right? So we will look into this in our next session definitely, because I feel that there's a few more things that we need to cover from the PBF. But just for the sake of completing this topic today on a very basic note, I'll go ahead and click on OK. We'll discuss about what enforced symmetric return is. We have already discussed the symmetric return in our ECMP part, right? Let's go ahead and click on OK. Click on commit, commit. Let's wait for this to finish. Okay, almost done. Okay, so the commit is successful. Let's close and let's go ahead and try to open some new websites, right? So whenever we do a new website, it will try to do a DNS query. Mm, let's see, Canva, Pixel, Apple, Sony, right? So definitely Canva was not open before. So there has to be a DNS query. Let's go ahead and see, do we see that DNS query or not? Let's go to the monitor tab. Let me filter this DNS base. There are a lot of logs, right? So I don't, I mean, it becomes difficult to understand what's happening. So now you can see everything is this DNS base, right, is going through 1/2 only. Okay. Till here, the ECMP load balancing traffic we are able to see 1/2, 1/1. And from here on, you see it's 1/2 only, right? Let's try to uh, send some more traffic so that this is validated. Mm, Let me clear those sessions. Just give me a second. There might be some existing sessions on the firewall. Let's go ahead and clear them. Okay, we have cleared all the session. And let me take let's have a look at this one, if the PBF is taking a hit or not. Let's see that. Okay, 3228. uh what I'll do, guys, I'll have a look at this. There is, for some reason, I'm not able to see PBF taking a hit as well. Okay, I guess some things are not as expected. Okay. What we'll do, we'll take this topic in our next session as well. And we'll see the application part and what's uh, what's not working with this PBF as well. I'll have to see where things were going wrong, because I see 1/1, 1/2 as well. And when so if we go ahead and see the sessions, I don't see a PBF taking a hit, right? If let's see this policy is taking a hit at all or not. So trust any and so there is a zero hit count for this rule, right? So this policy is not taking a hit. Okay. No worries. I'll do one thing. I'll check this. Why first of all the applications are not being shown over here, and based on that we'll be able to take it up further in our next class. Okay, no worries. I think we are good for today's session. I think we already extended it by 10 minutes. Let me stop recording.